paper the list of the company. They are already members of DVN. You could see all the car makers, most of the car makers, most of the tier 1 supplier and the tier 2 suppliers. You have that in your paper. You have in front of you. And also, very important point is that Driving Visual News organize twice a year workshop where the people, the automotive lighting players around the world, most of them, are present to talk about the future of automotive lighting and to talk together. It's really a good networking place. Some example about the workshop. We have done workshop in Stuttgart, Germany, in Paris, in Detroit, in Japan, in Shanghai, and we finished the workshop in Seoul last month. And you know that now we have in all the workshops we have more than 200 participants. You can see that the two last workshops we had 220 participants in Paris and 200 participants in Korea. Now we are in Moscow and we are planning a workshop next year in Shanghai and in Detroit. And maybe if there is some interest in Moscow, is the reason why we are, Ralph and me, we are here, we could organize also a workshop in Moscow with the worldwide experts explaining, presenting the new technologies. Okay, this it was a small advertisement for DVN. Now maybe we can go directly to the speech. The speech from the first part is about the past, present, and future in the light zone.
Good morning. After Hector's speech, the wake-up speech, I'll try to wake you up a little more. I think for me, first time being in Moscow, I've done a lot of trips through Moscow, through the Sheremetyevo airport, stopovers to Asia. It's the first time I'm really in Moscow. I enjoyed it. It's a city which is quite different from a lot of other cities, which is, for me, interesting in that sense. I don't know whether it's better or worse, but it's different from quite other cities. So, I'm happy to be here. I'm happy to enjoy. I'm not happy to enjoy the empty seats here, but I'm happy to enjoy the filled seats here. And I hope you can enjoy from the speeches of me and of Hector. Topic is past, present, and future of light sources. In my part, I'll have a little about the past, more about the present, and I hope a lot about the future, because the future of light sources should also encourage the lighting industry in Russia to go along the lines of the future, or at least to adapt to the lines, and maybe at some point of time, 5 years from now or so, lead the lines of light sources and lighting industry in the world. Okay. First of all, I will have 2 slides about the history of light sources. It's important just to understand how is lighting going. Then, where are we at this point of time? What is the future of the technology division? And point number 3, I think, Hector, is still in your presentation, but it is not. I will not talk too much about it. History of car lighting. History of car lighting. if we see the history of our business is just dating about 100, 110, 120 years ago. The first car, I think, was invented by Gottlieb Daimler. You know Daimler? It's Daimler-Benz. the guy who first invented it, it was basically a carriage which had some motor inside. It started around 1900, and at that time, point of time, the lighting was a candle. It was not to see, it was just to be seen. That no one hit the car, and therefore they had a candle. And that in, I think it is, sorry. Where do I have the laser pointer? There. Afterwards, I think 1905, as a big revolution, gas lighting was coming. A sort of gas candle. And if you, for example, watch the website of Driving Vision News, just 1 day ago, it was made reference to the gas lighting, a gas candle, which was a big revolution. And since then, you can see a lot of improvements in car lighting. Incandescent bulbs, halogen bulbs, xenon bulbs, and at the end LEDs. So you can see in car lighting that a lot of improvement steps and short improvement steps have been taken and are taken in the last years. And car lighting, and Hector will elaborate on it further, is one of the key drivers of car industry, of the face of the car, of the selling features of the car. So car lighting has become, in the last years, one of the important features. And you see it here also. Look, this was a candle in the beginning. Gas lighting, big headlights and so on, and becoming slimmer and slimmer, becoming more functions and so on. And you see in parallel the development of car design. So lighting, at least in Europe and at least in Asia, maybe to a little less extent in the US, is one of the drivers of selling a car to the public. Have this in mind when you talk about car lighting. Car lighting, front lighting, rear lighting is a selling feature of a car. So if you want to make an ambitious car looking good, look on lighting. Next one. I don't talk too much about this. Here you can see the development of luminous efficiency, lumens per watt, for those who know what it is, against the years. You can see here halogen lighting, you can see here normal lighting, and you can see here LEDs. You see the very steep increase of lighting in halogen devices, of the luminous efficiency. So, I would say, and I'm a guy coming from halogen and HID, but I would say LED lighting will be the future. And I will show you another graph which shows where the efficiency of LED lighting will go. So please, if you here in this area in Russia want to front lead, think about LEDs. You may be able to, instead of following this slower movement of halogen or HID type of light sources, if you follow LEDs, you may be on the curve of frog leaping. Think about it. Don't go to the old technologies. Think about frog leaping. Okay. What do I do wrong? What is the current status of light sources? Current status and maybe also a lot of something of history. Who of you knows HIV auxiliary? Two? Are there some more here? No? You don't know HIV? Three? I see some authorized. You don't know HIV? Xenon? Did you know xenon lighting? Okay. 2.5. Yeah, xenon. Xenon is, okay, if you don't know it, I have to say some words about it. Who knows halogen? Oh, okay, I would say more than 50% of the public. Who doesn't know any light source on car lighting? Who doesn't know any light source on car lighting?
Which one?
Who doesn't? Who has a car? Who is driving in a car? Sometimes. I think all of you. Yeah, okay. I'm not prepared for this speech now. I'm just... do you know how important car lighting is? You should know that according to research around the world, and I don't know what is it in Russia, in China, in Europe exactly, do you know that 60% of all fatal accidents means people being killed is happening under dark conditions due to bad lighting. Do you know that most of the people killed, under the 60%, are pedestrians? Maybe as a car driver, you don't care so much. But as a society, we have to care about fatal accidents in nighttime. And therefore, driving is so important. Lighting during driving is so important. I think, even as a forceful car driver of a BMW 5 or 7 series, or what I see here is a lot of Mercedes S-Class, you should care about killing people at the roadside. That's one point. The other point is, and I don't know about Russia, but I know about US, I know about Europe. You have more and more elderly people driving cars. And most of the elderly people, at least in Europe, maybe it's different in Russia again, have the power, have the money to buy big and speedy cars. So, if you compare, I don't have the graphs here. I'm now 64, going to 65 soon. I see only 20% of the light I had this when I was 20 years old. So the vision capability of people is going down quickly. One of the solutions, and we are really working on it, is to give better car lighting, to improve the vision of elderly people. Nobody wants to hear that, of course. But please, once you get older, there are two options. Get better car lighting, to see more, not to hit pedestrians and so on. And the other is, of course, repair your lenses in your eyes. I've done that 1 year ago, it works perfectly. I don't know about Russia, but if you don't want to repair your eyes, go for better car lighting. Okay, just to make you aware how important car lighting for road safety is. In Europe, or in the western part of Europe, let's say that, the first xenon was introduced on the BMW, where do I have it? On the BMW 750 IL, extra long, more than half a meter longer than normal. It was a revolution because it yielded 3 times the light of an halogen bulb. So it was really a revolution. But it was a high-end. That car was built with 2,000 cars a year. So not for the public, just for the high-end, the people who could buy it, but also the people who wanted to be different from others. In the meantime, a new version of Xenon has been launched in China on the Tiguan, and it is on the Tiguan. It is a standard version. No halogen anymore. You have HID 3 times the light of halogen on a Tiguan as a standard version. So no extra price on it, no uplifts. So it is becoming more and more standard. By the way, just before LEDs arrive. As another state of the art, which is at this point of time, I think available on about 30–40% of all cars, is that in the rear lighting you have LEDs. LEDs is a buzzword, I will come later to that. Light emitting diodes, they have quite different characteristics than the normally known halogen or HID bulbs, and it is becoming buzzword, and not a buzzword, I wouldn't say a buzzword, it's becoming becoming to public in signaling and in rear lighting. Because LEDs have the advantage that they immediately switch on. If you look to a halogen bulb, the halogen bulb needs about 0.3 to 0.4 seconds to come to full lighting. Reaction time of a human being is 0.8 to 1 second. So if you can reduce the upcoming upcoming of lighting by 0.4 seconds, you reduce the reaction time of a human being to about the half. So you can really, by LEDs in the rear lighting, you can avoid accidents. Or let's say make the distance to a car up front, especially also in city driving, a lot shorter. So this will come in mid-power LEDs. High-power LEDs. Who in this circle knows about high-power LEDs for high beam? I see 2, 3, 4, 5. Okay, at least there are more people knowing about LEDs than about HID. So I think you're on the bridge to front. send on to LEDs. Okay. LEDs, yeah. For the people who don't know LEDs, what does LED mean? Okay, not for the people who don't know it. LED means light emitting diode. LEDs are light source, which is not like normal light sources heating up a Wolfram wire to 3000 and more kelvins. LEDs are, I would say, like semiconductors. I think most of you will know semiconductors, but their consistence is in a way that they can emit light. You all know, I think, transistors. Who doesn't know a transistor? Who doesn't know? Who doesn't know a transistor? Yeah, this is the negative question. Nobody raises his hand. If I ask who knows a transistor, it would be different. So you have a PN junction. Transistor invented, I think, 50 years ago, 1948 or so, by some Americans, and they all govern our life at this point of time in your handy, in your television and so on. The big thing is that people were able to make out of it in this short, very tiny junction of the transistor to get light out of it. This was done first by Hewlett Packard and so on. And there are some companies in the world now, like Lumlets coming from San Jose, in the meantime acquired by Philips, now spin off by Philips, like Nishia in Japan, like some Koreans, and I do not have, I had some rumors or some talks about also that also here in Russia there are some movements to be in this innovative, and I think I would call it the dominating technology in lighting 10 years from now. This is LEDs. And let's go back. It was first used on a car in 2007 by the Japanese on a Lexus LS600. Very high level car. Then Audi on the R8, just to give you an impression. LX600 has, I don't know, they did less than 10,000 cars. The R8 was R8. You know that car? Yeah, it's a sort of race car, legal on roads. In 2008, by the way, one of the first owners of this car was Elton John. You know Elton John? Yeah, the musician, getting old in the meantime, but still in the press. I think he paid 350,000 euro for that car. Not only due to LEDs, but just to be one of the first to get the car. He ordered it 1 year in advance. And we see, I'm too big. And we see LED lighting. This is from Nishia on the LS600. This is Altilon from Philips on the R8. It's in a very quick phase in Japan and in Europe. In Japan, people use it due to energy efficiency. They build hybrid cars. The Japanese are rational people. The Europeans, or a lot of Europeans, at least the German car drivers who can afford such a car, emotional people. they want to be different. They want to show up a difference. They want to make a statement. I'm different on, basically I'm different on the higher side of the pyramid. So therefore, lighting in Europe, LED lighting in Europe is going a lot around being different in the car. The Japanese are more rational. I want to care for the environment and so on. Okay. Next one. Did you hear or did someone hear about laser lighting? One, two, three, four, five. Yeah, you also. You also. I know with that. What is the impression about laser? What? Two. Great, but too expensive. Look, if I look to laser lighting, first of all, for me it is Star Wars. It is Star Wars. I shoot you. This laser lighting in automotive is not really like that, but it has some affinity to it. If you before I talk about what you can do with that, I just want to explain what it is. And then afterwards you will see why I say it has a little to do with Star Wars. I'm too far. You have a laser diode. In the meantime, you can make lasers. In the beginning were, I think, were machines which could fill at least half of this room to get a laser, to get a focus beam out of it. In the meantime, I think it is, it is in the area of this size here, and this size is about, I would say, 1.5 millimeters. This is 2.5 millimeters, and you can get out of such a diode 2 watts of blue light, which is a lot. If you compare a halogen bulb of, for example, 50 watt, you get out of it about 3 to 4 watts of visible light. Not only in the blue, but over the whole spectrum. Out of such a laser diode, you can get, in the meantime, 2 watts of blue light. And you focus this on a phosphor plant. Who knows phosphor in this room? Who doesn't know phosphor? Now all the other hands should rise up. No, what is happening in phosphor is that, okay, I see you have LEDs here. Yeah. Okay, I cannot explain it. But before you had tubes which were covered by phosphor. They, in the interior, you got blue light, and then phosphor converted it to yellow, red, and green light, which you need for white light. So this blue light is focused on a plate of phosphor, and the blue light is a little dispersed in different directions, and the phosphor converts the blue light to yellow light, and in total you get white light out of it. What's the interesting thing with it? Instead of having, let's say, I don't have it now, instead of having a fluorescent tube with phosphor and compared to this laser. With this laser, you get a very focused beam on the phosphor plate. And you get a very high intensity of light out of it. And if you look to the laws of optics, the higher the intensity of the source is, the better you can focus it. So that's the miracle behind this laser lighting, which will be the next generation of solid-state lighting, and I'll show you later what you can do with it. I will not explain all the details now, and go to the next slide. Hopefully. What can you do with this laser light source? We call it LIPS, means laser irradiated phosphor source. So, once more, laser irradiated phosphor, light, not light source, phosphor source. The laser radiates on the phosphor, and the light comes out of the phosphor. So it's not a laser which is on the road, it's light from phosphor. That's important to know. What can you do with it? The first cars have come to the public sector in June, I think, by Audi. And June, July this year by Audi and also by BMW. What they do, they have a very nice, very good LED light, but with this laser on top, they can irradiate up to 600 meters ahead of the car. 600 meters. It doesn't seem so important on crowded roads, of course, but if you're driving quickly on German highways, and I don't know about Russia, but I can imagine that in some areas where you have good roads, it can also be important. And I think Hector drove one of these cars, and he said, with this laser light, you also have a very nice impression, not only 600 meters ahead, you see a normal, and you see 600 meters ahead, but also in the foreground, you have a very nice impression. So it seems there are now two cars on the road, an Audi very special R8 version, and the BMW electrical car, i8, BMW electrical car on the road. It seems really to be an innovation which is coming quicker or surpassing frog-leaping LEDs. The other thing is, which has been investigated, for example, by Valeo, French company. Hector was the development manager, I think, now 10 years ago or so, guiding all the innovations. They say that with laser lighting, you can make headlamps with the same light output we have today on the road, which are only 10 to 15 millimeters high. Can you imagine what that means? Like this. You can make a stream on the front of your car. Can you imagine what that means for design of a car? Of course, still we have big headlights. People will still use big headlights, but they have the opportunity to have this string of light, and for the rest you can use daytime running lights, you can use something else, you can use night things. So the opportunity for car designers with very thin headlights is enormous. It's really enormous. So it's not yet there, it's starting. Maybe it takes another 5 to 7 years, because these type of headlights are really in the market, but I'm sure they will come. They will come. And then the Japanese, pragmatical as they are starting with LED lighting and combine it with laser lighting. You know, the Japanese, as far as I know them, and I've worked a lot of time in Japan, they are not the real front runners in innovation. They are not the inventors, but they are pragmatical to apply and to use new technologies on a broad scale. So I think they will go with a combination of lasers and LEDs. Yeah, here you can see on laser light sources, here you can see the development. BMW was the first to show us, to demonstrate the show car in 2011. Now, 2014, I think you can buy it if you have the money. If you have the money, and if you have the patience to drive with an electrical car, because after 150 kilometers, you have to recharge the car, of course. So, will be the i8 of BMW. The headlamp looks like this. You still see the icons of BMW, you know, the round lenses. In the Le Mans 2014, where Audi again for the third time in a row gained, they had laser headlamps, and in Japan they had the first street legal prototype in 2013. Okay, I think I have to speed up, otherwise I take my time. You are still listening, or too slow? It's okay for you? Another important thing, OLEDs. Who did ever hear about OLEDs? Nobody? Oh, okay.
AMOLED.
More than about lasers. OLEDs. What does OLED mean? From the people who have heard about it, what does OLED mean? Exactly. LED is light emitting device, and OLED is an organic light emitting device. What does organic mean in that combination? Not only for the people who know OLEDs, what does organic mean? What? Something which is combined with life, exactly. What is important for life, for our bodies? Why do we live? There are two very important, I would say, elements, molecules, and so on. One is water. 96%, as far as at least I've learned at school. I don't know whether it's true nowadays. 96% of our body is water. If I look to myself, okay, I cannot imagine that's only water. Maybe also a little beer or vodka. That's one thing. The other thing is, the second most important element in our bodies is carbon. C. Carbon. So everything which is related to carbon is called organic. So if you talk about OLEDs, it has nothing to do with growth of plants or with these type of things. It simply means that in the LED or in the OLED, instead of the LEDs you have indium, gallium, nitride, and so on, additional to these elements, you have carbon in it. So it's not organic LEDs, OLEDs, that you can grow them like plants. Don't expect that, at least at this point in time, I don't know it, but maybe there's a professor who knows about greenhousing, and he will grow OLEDs, would be a revolution. So OLEDs are meant, it is inorganic materials, including carbon. Okay, OLEDs are different from the typical light sources we have for car lighting. For car lighting, normally you have lights, small light sources, which can be focused far away. In OLEDs, you have basically you have a substrate, mostly glass. You put some organic layers, and organic means something including carbon, not growing like a plant. You don't have to be anxious that this organic layer grows, and it is very vulnerable if you get oxygen or water on it. Therefore, it is covered by an insulating layer of glass, and you have two contacts, and then out of this plate a rather homogeneous light is coming out. If you look here, for example, to the top, you have all the light sources, you see a distributed light coming out. With OLEDs you can make a very homogeneous surface, which you, not as OLED, but in other areas already see on the rear of the car. The people like to go away from, at this point of time at least, from spotted light on the rear of the car to homogeneous lighting. That is, whether it's useful, I don't know, but people like it. So car lighting is a feature of selling a car, of doing something which people like. And with OLEDs you can do a lot about it. Here we have, you don't see it so well. Here we have a picture where a Bentley is lighted on nearly all the surface by OLED spots, and on the top in the showroom you also have OLED lighting, just to see what the possibilities are. Okay, I skip that. We have a revolution in lighting, in car lighting at this point of time. For you, Semmel's research institutes, what will be the future 10 years from now? And I think it's important for you, because you are in the embryonic phase of car making, of car lighting, but do you want to travel behind the evolution, or maybe here in Russia could also be frog leaping to the front of the evolution. And we think that halogen lighting will drop to 40% in about 10 years from now. We see that LED lighting will be about equal in the worldwide market. I must say, in the worldwide market. You have low cost markets, high cost markets, will be about equal 10 years from now. HID will drop, because HID will be replaced by HID xenon will be replaced by LEDs. LED is the next light source, and it will disappear somewhere, let's say 10 years from now. Whether it's 3% or 5 or 1 or 0, nobody knows for new cars. But we also see additionally, and I think that it should be interesting for you, that the laser lighting, and we call it laser hybrid, laser lighting combined with LED may already take in 10 years from now a market share worldwide, which HID xenon has now. So if you as an industry or you as researchers want to focus your activities, please look into LEDs and look into laser lighting. Especially laser lighting could be very interesting. For real light sources, okay, the normal incandescent will drop even more significant than halogen, but it is coming more and more. So if you design new cars or lighting for new cars, for real lighting, I think LED is a must. LED is really a must. And what you see here, the hybrid, which is a combination of the OLEDs. I will explain in the next slide or so what it more means. OLEDs and LEDs will also be coming winning opportunities, at least for high-end cars. You know, in high-end cars you want to be different. Yeah, that's why you buy a high-end car. For transportation, you can take a mid-size Ford Mondeo. Yeah. You buy an S-Class, Mercedes S-Class or Bentley or whatsoever to be different. And in these cars, OLEDs will make the difference in real lighting. So therefore we think, not everybody of course can afford a high-end car, so we think but a reasonable market share. Now to the future. Wait one more. Who knows what is the efficiency of LEDs? First question. Who knows how is the efficiency of a light source measured? 1, 2, 3. Okay. Efficiency of a light source is measured in lumens. Lumens is the light output per watt electrical energy you put in. Who knows what, from a physical standpoint, the maximum efficiency of a light source can be? 1, 2. Alexei? No, not really. It is 683 lumens per watt. That has to do with how it is defined and so on. So you cannot reach more than 683 lumens per watt. That's the absolute maximum. If you have a light source which is just emitting in the green, who knows what, at this point of time, the normal efficiency of light sources is? 1. Yeah, okay. Halogen, how much?
Well, even at 30,
25 to 30. 25 to 30 lumens per watt is for halogen. At least automotive halogen, H7 for example, is 30 lumens per watt. Who knows what for gas discharge light sources for? Xenon HID is the efficiency is. What?
150.
No, the automotive is, I would say, 80 to 100. You're right, in general lighting light sources you can come up to, depends, between 120 and the highest light source we have at this point of time is low pressure sodium is 230 lumens per watt. So as normal, when you have a physical limit, at this point of time we are reaching about 1/3 of it. So just to give you, and the physical limit is 680, we are in real life to 1/3 of it. Something like 150, something like that. Just to explain the next, or to prepare the next slide. If we look at to LEDs, and LEDs is the light source of the future, you see here 2013 for automotive, and I say for automotive, we are around 1 100 lumens per watt. Remember, 680 is the limit. We expect a further growth of the current technology to about 150 lumens per watt. So in the next, let's say, 10 years, the efficiency still can grow by 50%. But, and that's important, for LEDs, there are, I would say, more than rumors. There is research ongoing which could boost the efficiency again in a stepwise increase to about 250 lumens per watt. Which would mean that LEDs will be the most efficient light source, giving a broad spectrum in the world. So research is ongoing, and you know research needs some time, but about 10 years from now, we think that LEDs can go to 250 lumens per watt. Which means, if you think back, with our halogen light sources at this point of time, we have 30 lumens per watt. So we need, if you have a good halogen light source, 55 watts. You can imagine that 10 years from now, you only need 5 watts. Which is very important for especially electrical cars who don't have the power. You don't have to spend so much. So with 5 watts on electrical cars, which can be the future, you have a very big advantage. On the other hand, and I think it's important for Russia, you have to find a way that your headlamp doesn't freeze. Because nowadays, the light sources with the power, with the energy, heat up the front lens and there's no snow on it. Once you only have 5 watts, who takes care of the snow? So, but there are inventions like circulating and so on. But for Russia, I think it's important with low power light sources, how do we deal with minus 50 and snow and so on. Okay, next slide. This one I know. What's interesting with the laser system? I showed you, I think, the laser. You focus a laser beam, so a very straight beam, on a phosphor to generate the light. This gives you a unique possibility if you want to make variable beams. And Hector will speak about variable beams, ADB. Who knows the abbreviation ADB? One. Even ADB, adaptive driving beam. You know, okay. Yeah, he was in Korea workshop. He knows, of course. He's heard about it. ADB. Hector will tell you about the newest technologies we have in checking beams, because okay, I don't want to talk too much, but in Europe at least, I don't know what the habit is in Russia. You have the low beam, which doesn't shine so far, because you don't want to glare the upcoming traffic. With the adaptive driving beam, for the driver, you have a high beam, which doesn't glare the opposing traffic. I think it's a very important, maybe a very important invention to really reduce the night traffic accident. And with this laser, you can do it easily. Where is it? What you have already in multimedia, projectors and so on, is that you have a blue laser going onto a mirror, and then it is going onto phosphoring. It means there is different, there's a wheel constantly turning with different phosphors, and you can adapt the light color. The other thing is, let's go back. What you can see here, that you focus some lasers via mirror onto variable mirrors, moving mirrors. In that way, you can create a beam which is variable on the road. And if a detector sees a car in front of you or opposing, it simply dims down the lasers in that area where this mirror focuses. So this is what we call scanning mirror synchronized with output modulation. In that way, you can get you can always ride with high beam, except if a car opposes you just in the area where the car is coming, you dim down the light. So it's by the way, next week in Driving Vision Use, we will have an article about this type of technology called matrix beam. So really, this is a revolution in the scene on even with opposing traffic. This will come, and this, in my point of view, maybe even regulators, governments will demand this on normal cars, because the revolution in good seeing, remember 60% of all fatal accidents during night time, and this is a revolution which can reduce it. Hector will, I already took some of his talk. Sorry, Hector. Next one. OLEDs. What's the problem of OLEDs at this point of time? I showed you you see it here. At this point of time, OLEDs are made on a flat surface. It's a glass plate. Glass you cannot bend so easily. There are Japanese companies, by the way, who are delivering glass plates with a thickness of 0.1 millimeter, which are bended. But a glass plate of 0.1 millimeter breaks very easily. And you can imagine in a car, with all the bumpy roads you have, not only in Russia, but in the meantime in Germany, because we don't have enough money to repair all the roads. On bumpy roads, this can break. So the next generation of OLEDs, which is important, is that you don't have this flat glass plate, because if you look to real lights, they are bended around, they have nice shapes just to exaggerate the size of the car. So let's switch to OLEDs again. So we have made a roadmap here of how we see how OLEDs will come for real lighting. And you see, one of the important things is there are already prototypes at Philips and at Osram and at Gazprom firm of banded OLEDs, but it's only 2D. If you really want to make a nice rear light on a car, you need it three-dimensional. Yeah, just bending is not enough. You need it three-dimensional. And we think, and this is what we call the holy grail of OLED technology, that in around 2013, 2020, 7 years from now, 6.5 years from now, who knows whether it's 5.5 or 8.5 from now, you really could have OLEDs which are 3D bendable. I think 1 year ago, Audi has presented the first prototype of a car with 3-dimensional OLEDs. But it was made in cooperation with Philips, with Automotive lighting, and Audi and University of Cologne in Germany. It was a totally different technology than OLEDs are made at this point of time. But it is possible. So physics laws don't forbid it. So we think that around 2020, 3-dimensional OLEDs will come. And at that point of time, the shaping, the design at the rear of the car is really open. If you see an OLED, I showed it on the other side, it's 2 millimeter thick. Think about that you do not have to drill holes in the body of the car, but that you simply glue it onto it. I don't know who here, nobody here is in the body of the car today. But if you know how much more stability a car can get, if at the end you don't need to drill holes for the rear legs, how small, how thinner the sheet metal can become, what you can save on the total economy of scales of a car, OLEDs can be the revolution for cost-wise, but also you can design every shape of headlamp behind. Here is an Audi, I think it's an R8 with OLEDs. Here, there. Can you imagine that? By the way, this is just a computer animation. There is no such car on the road. But can you imagine what OLEDs can be for the styling and for the styling opportunities? Factory, just to give you an example, what it means with OLEDs. Philips and Osram have invested in, I think, both together, not both together, everybody separate, about 1.5 years ago, for a pilot factory. Pilot means you can make maybe 1 million pieces per year, which is a lot, but look to the total car market, is 100 million per year. So for such pilot factory, they have invested 40 million euros. In rubles, I think it's times 50, so it should be something like, what is it, 1 million? Yeah, 2 billion. That's for a pilot factory in OLEDs. And that's the big challenge, of course, for the industry. And we cannot make it only for cars. OLEDs are also used in the displays of handies. There's, in the meantime, LG from Korea has announced a bendable TV. Can you imagine? You have a TV which is bent. It costs, I think, 50,000 euros, something like that. But that's where the OLED driving is coming from, and that's where the OLED drive is coming from, and we from Automotive benefit from. So that's the industrial point of view. Roadmap 2016. I think 2 top European car makers will have OLEDs as a position light. The yellow turn light will come 1 year later, and the stop lights will come here, and then in 3D in 2020, the game is over. So, if you, from your point of view, look to innovative technologies, don't forget OLEDs. I would say different. Focus on OLEDs, among others. I think last, yeah. Just one slide. How will cost develop in general? We think that halogen will go down sometime, but due to reduced capacity, due to reduced usage, will grow. HID will further go down. LEDs still have the potential, they are very expensive, still have the potential to go down, and lasers are, at this point of time, more expensive because I've all put on 100%. Lasers are about 10 times more expensive than LEDs at this point of time, but with more usage, they will drop heavily, like LEDs did in the years before. Last but not least, we think that halogen lighting and for rear also incandescent lighting will remain longer than 2030, because you will, I would say, never, or at least in the next 50 years, you will not reach the cost competitiveness of halogen bulbs. If you have an LED, the LED is more expensive, you need a driver, you need a cooling. So from system point of view, halogen bulbs are really on top if you want to have cost competitive solutions. It's halogen bulbs. We think that xenon will disappear, you saw it in my graphs, around or until 2025. Because xenon HID is expensive. It is very good lighting, no doubt. It's expensive, but at that point of time, 2020, LEDs will as good and as cost competitive. More than halogen, but if you want to have really good lighting, at this point of time you go to HID, xenon HID, but that will be LEDs. And this is the third line. We think, and there are a lot of discussions about it, the laser technology will evolve until 2025 combined with LEDs. I gave you some of the advantages of laser technology. You can remove it from the phosphor, from the light source where you have it. You can, by a mirror, you can simply, not simply, but you can have adaptable beams. So we think that laser can become a technology, I would not say competing with LEDs, but taking their shares in combination with LEDs. It's a new technology coming up, quickly coming up, and some people don't like it, because the LED guys, yeah, okay, we have invested a lot and so on, and now new technology is coming, but that's what we think. And what I try to point out to you is OLEDs really can lead to a revolution, yeah, from the way how you design a car, but also from the flexibility you have and the design possibilities in the signaling area. OLEDs will never have the possibility to give an luminance to be in headlighting, but they can lead to a revolution in SIG lighting, and we think from 2020 it can go on. I think that's all I wanted to say. Do we have some remarks, questions? I put some questions to you. Now you are in the shape to put questions to me. Otherwise, in 2-3 minutes, Hector goes on. I talked about light sources mainly and their possibilities. Hector will talk about lighting systems, what they are with electronics and all the electronic revolution in car lighting. But just give you a chance. Put some questions. If not, I like to be photographed. especially by such a nice photographer. You don't need to translate that.